And 9 in the morning is kind of a brutal start, but all right. So let's just kind of dive into it and talk a little bit about what we're doing here today. So basically, I've structured the tutorial as a series of 30-minute blocks, because I find that much easier to think about in terms of teaching, and I think it's also much easier to think about in terms of learning. So the first 30 minutes is basically going to be an introduction to the tutorial. The next 20 to 30 is going to be just kind of getting started, getting everything installed, getting just a basic Sphinx project set up, and just like some of the introduction to kind of the concepts. Then the next 30 minutes is actually diving into restructured text and Sphinx and really kind of getting your hands dirty with a lot of the markup and actually making your documentation do stuff. Then we're going to have a 20-ish minute break, so there will be snacks and all sorts of good stuff. Hopefully coffee, some other things outside. Then after that, we're going to go through and actually build out a reference for a Python API. Like we have a little, one line or one file Python library, and we're just going to build some automatic API documentation for that. And then the last part is going to be mostly actually learning how to test that Python code in your documentation so you can test the examples, and then also just actually uploading that code to read the docs so it's published and available on the internet. And then at the end, we have about 15 or 20 minutes for questions and if there's specific things that people want to ask me or just kind of delve a little bit more into different topics, that's the time for that. And then there's a bunch of things as well that if you want to kind of go off on your own and learn about, how do I do Markdown? How do I do Django stuff? How do I do tables and some other RST stuff? The tutorial has all that. So the structure of each of those 30-minute blocks is going to be about, me standing up for about 5 minutes, introducing what we're going to learn and the tasks. Then there's, about 15 to 20 minutes of you all doing stuff, and then we'll be walking around the room, answering questions, making sure you're not stuck. And then at the end, there'll be another about 5 minutes or so where we just go over what we learned and just kind of show what the finished product looks like. So how this is going to work, so Brandon Rhodes, who's standing right outside, who's the chair of PyCon this year, gave a Sphinx tutorial for a number of years at PyCon, and he gave me some really good advice, which was, give everyone the content that you want them to work with and have them actually go in and mark it up. Because I don't want you all just sitting here actually writing like human words into a text editor, right? That's not a good use of your time. So each of these tutorials is actually going to give you a block of text that is not marked up in any markup language. It's just kind of plain text. And then you have to go in and actually add the Sphinx and restructure text markup to those files so that it does what you want it to do. So this saves you a whole lot of time from actually sitting around typing, and is much more about like, oh, how do I make a note in a document, or how do I link to this other page in a way that makes sense? So it saves you some time and actually really lets you focus on the content that we're trying to learn here. And then each step has the rendered HTML so that you can actually see what it's meant to look like, and then you're trying to make your local version look like that. And then each step also has some extra credit. So if folks are a little bit faster than others and you get to that point, feel free to do those as well, but if you don't get there, it's not a big deal. So the project that we're going to be working on is documenting a basic web crawler. So it's just a little command line utility that goes out and like crawls a website. It's pretty simple. The code is not beautiful. It just has some basic documentation in the source file, but it makes a nice simple example to actually document. So at the end of this tutorial, the goal is for you to have a complete set of documentation for this web crawler project. You'll understand how it's built and how Sphinx works and the inner workings of those tools. And then you'll also understand how to host it on Read the Docs and keep it up to date and available to the public forever. And so this is the second time we've done this tutorial. We gave it at DjangoCon last year, and everyone seemed to like it. But please let me know, at the end. We are always trying to make stuff better. So let me know what works well, like the parts that you really enjoyed, as well as, if there's stuff that could be improved always happy to have those conversations as well. And so yeah, I definitely need to thank Brandon, who conveniently enough is standing right outside the door, and also all the authors of Sphinx, because it is a really wonderful tool that I actually didn't write. I have some patches in it, but it is a really, really phenomenal documentation tool. All right, so now the introduction to Sphinx. So I do want to give a little bit of a shout out to kind of what good documentation and how to think about documentation for software. So there's a lot of talk about what good documentation is, and I think it's really does depend on what your use case is and what your library is and what you're actually trying to document. But in general, there's three kind of high-level ways that you can think about like structuring and writing documentation. And that is really about what you write. And so these are generally kind of thought of in the Python and Django worlds as tutorials, topical guides, and reference material. So tutorials are going to be the things that actually introduce people from kind of a beginner level into your project. And this is super, super important, right? It's like I'm new to here and I don't know where to go. Direct me to this place that's going to be a 15 minute to 1 hour long introduction to the project that will like guide me along the way and really introduce me to the concepts. Topical guides are explaining kind of the subject matter and how your project relates to it. So if you're building like say a web crawler, you should be like, what is web crawling, and how does one crawl the internet in a way that's like that understands robots.txt and all these other kind of things. They're much kind of higher level and just contextualize your project in the kind of problem space that it exists in. And this is where you might reference kind of other previous implementations, inspirations, things like that. And then there's also kind of pure reference material, right? Like I'm just trying to use your library to like do something, and I just need to know what arguments this function takes. This very kind of more auto-generated like Java doc style documentation is important for technical users, but a lot of projects only have reference material, right? Like that is kind of, like we just took our code and we generated an API reference and now our documentation's done, right? Like that it's an important part, but it is very much like just the beginning of what good documentation has. And so for more information about this, Jacob Kaplan-Moss, one of the previous BDFLs of Django, has a really fantastic blog post that is all of what I said written out in multiple pages and more depth.
Are the slides going to be available?
Yes. Yeah, so you will have the slides afterwards. No need to scramble like crazy to write these down. So I also do a conference called Write the Docs, and we actually have a beginner's guide to documentation that talks through a little bit about what I'm talking about here as well. That's another good place to kind of point people. And then also there's Steve Losh has a great blog post called Teach, Don't Tell. That's another just like treatise on documentation that it's an hour to 2 hours of reading, but it will really kind of contextualize what writing good documentation means. So I always like to give people a little bit of ammunition around why writing documentation is important, right? You're sitting here in a 3-hour tutorial. Hopefully you already believe that this is a skill that you need and it's something you really need to be able to do. But you're not the only one within your organization, right? Like you need to be able to convince other people that writing documentation is important as well. And this is really how I like to kind of think about these arguments. And my favorite arguments for programmers is a selfish appeal, right? I don't know how many of you have had the experience of looking at code that's like maybe a year old, and you're gonna do a git blame, and you're like, please, hope I didn't write this, once you write code and you kind of move on and it just kind of sits there and your brain moves on, it's indistinguishable from code somebody else wrote 6 months ago, right? Like it's really hard to know who's gonna be maintaining that code in 6 months from now. And so if you actually write things down and be like, hey, we made this design decision because XYZ, and you can kind of like take the state that's in your mind when you're actually writing software and write it down so that it's much easier to kind of reload it back into your brain later. And that's one of the best reasons to actually write documentation as a developer. As an open source developer or a developer inside of companies, right? Like, if you want other people to use your code, you have to allow them to use it. You know, it's like you have to onboard them, you have to tell them what it does, you have to really kind of make it easier for folks to use your code, whether it's just some random, you know, like how many of us are gonna go to GitHub, and if there's a repo without a README, we're gonna use that code? Like that doesn't happen, right? Like you need to have that kind of on-road into a project with the documentation. And a README is a great start, but you also have to do a lot more if you really want people, you know, how do I install this? You know, what is it meant to do? What other problems does it solve? How do I actually use it? So writing documentation also makes your code better. So the act of kind of writing down what you're going to be doing and thinking through the problems that you're solving before you actually write code is a really, really fundamental way to build better APIs. Kenneth Wrights, who built requests and a bunch of other stuff, he has a really good talk about this, where it's like, yeah, like writing things down and thinking through how it's gonna work from a user perspective is incredibly important for building an API that's usable. And so building that little like README file that's like, here's how I use this API as a user, like before you write the code, it informs the design of the code so that it has a good API. And my last, and really one that I think people don't think about is, you know, as a modern software developer, all we do is write. You know, it's like GitHub issues, email, code comments, commit messages, like 80% of the communication that we have with other developers is written. And by writing documentation, you become a better technical writer, which is a fundamental skill in what development is today. And so, you know, the more you practice and the more you kind of get good at actually explaining yourself in the written word, and the best way to do that is just to do it more. You become a better writer, and you also become a better programmer. All right, so hopefully people are like, yes, documentation, that's a thing that makes sense. So this is what we're gonna be talking about today. So just to kind of contextualize everyone, so kind of the inner chocolate core of this toolchain is restructured text, which is a markup language that is very similar to Markdown. Works in a lot of the same ways, but is solving a much harder and more kind of complex problem. Then restructured text is actually implemented by a library called docutils. So if you ever hear the word docutils, it's basically just the Python implementation of restructured text. And then built on top of these tools is Sphinx. And so Sphinx actually sits on top and provides a wrapper for documenting software using restructured text. And it actually extends the tool to allow you to really think and talk about software concepts, not just, you know, words and phrases. And then sitting on top of that, Read the Docs actually hosts Sphinx projects. So you can think about Read the Docs as continuous integration for documentation. So every time you commit your documentation to a repository, we'll get a GitHub post commit hook, and then we'll rebuild your documentation that's available and publicly hosted. So we're basically just a continuous integration for Sphinx that also, you know, acts as a public documentation host at the same time. So restructured text. Restructured text is a lightweight markup language. You know, wiki markup on, you know, Wikipedia, Markdown, ASCII doc. These are some of the other examples of lightweight markup languages. And they just work as a base format to generate other formats from, right? So it's like, I wanna have this single markup that I can make PDFs, I can make HTML, I can just use as kind of a single source of truth that generates other stuff. And it works really well with programmer tools, right? They're a plain text file that you can put into a Git repository, and it just works the exact same way as code. And that's really one of the main benefits for programmers using these tools. And so the way that restructured text kind of differs from something like Markdown is that it actually allows you to have semantic meaning within your markup. So who here knows kind of what semantic HTML is? Okay, there was like a big battle about this in like the 90s, right? Like, and it's basically allowing you to kind of say what something is and what something looks like in a different way. So kind of the classic HTML example of this is, right, like you wouldn't just say, you know, issues we put in bold. Like nobody wants to put issues in bold because then you don't know it's an issue, right? The proper way to do this in HTML is you say, you know, we have a span of class issue that has the issue inside of it. And then later, somebody in CSS can come along and say, all issues in this output are bold, right? So you've separated what something is from what it looks like. And this is a fundamental concept around semantics. And so HTML has been doing this for a long time with CSS. And this is really what restructured text allows you to do, right? In HTML, you wouldn't say, font red warning. You would say something like span class of warning that then gets colored red later. But then this is actually restructured text, which allows you to just say, this is a warning. And then that will be generated into HTML as a span with a class of warning. But it really gives you that same concept where you're really able to author and say just what something is, and then you can come along later in your PDF or your HTML output and then style it appropriately. And so the big way that this differs between something like Markdown, which is a markup that does not have semantic meaning. So if we wanted to link to PEP8 from a Markdown document, we would have to look up the web URL where the PEPs live and just create a hyperlink. Whereas within restructured text, we can actually say, I want to call this PEP function and give it an argument 8, and that will automatically generate a link to PEP8, right? And so this is something that's really cool that you can do within Sphinx and Python documentation, because this allows you, right, when something comes along and they update the Python website and the URL for the PEPs change, you have to this is incredibly difficult to update. Whereas this, you're just wherever that lookup happens and that link generation occurs, you just change one variable to where the URL points, and then all of your links automatically update properly. And so it gives you this kind of reusability within markup that you have in programming. So semantic markup's really, really important. It shows kind of the intent of your words, and it works across output formats. But I really like restructured text compared to Markdown. A lot of people kind of think Markdown is good enough, and I have a whole blog post, and we can talk about this later if you want to talk to me about it. But really, the end result is if you care about what your words are when you're writing them, you should write in a way that encodes semantic meaning, because it allows you to kind of write in a more powerful fashion as you're actually writing documentation. So anyway, that is kind of the philosophy behind restructured text and why it is a little bit crazier. So it is white space sensitive, very much like Python. It is extensible, and it's powerful, but a little bit awkward, right? And this kind of more expressive worldview that explains why it was created also explains a lot of the awkwardness, right? It does a lot more than Markdown does, but that does have some downsides in terms of complexity. And I do want to show just who here has actually seen kind of a restructured text document before. So 50% of folks. All right. So I think I've been talking about this in a theoretical way, but I think it might be useful to actually see what this looks like in practice. So this is, you have a title, and then you have some food and some text, and then you make a list, right? It looks very similar to something like Markdown, but then what you can do is you actually have a set of content, of directives, that allow you to do something a little bit more powerful, right? So this, oh, sorry, you can't all see that. So what this contents directive did is actually add a dynamic table of contents to the page that knows what all of the headers are inside of the page, right? And so that's the kind of stuff that you can do. So you can basically think of this as a function call to a contents function, and then the actual output is this contents that allows you to link to the different headers within a document. And so this is the kind of stuff you can do with restructured text that you can't necessarily do with Markdown, right? And if we add another subtitle, that automatically updates, and it has a whole kind of document model behind how it works that's much more powerful. All right. So there's two really big concepts in restructured text and how it's extensible and how it's powerful. One, which you saw with the contents directive there, is actually page level markup. It's kind of a full block. It's its own part of the page. And it's a line that starts with 2 periods and a space, and then whatever the kind of the function is that you're calling. And then that content actually can be indented, further down into a page, and it ends once you unindent it. Similar to Python, right? It kind of uses indentation to keep things within scope. So it looks like this, right? You have a dot, directive name. So in that example, it was contents. Similarly, it could be warning or note or any other kind of concept you want to do. And so the cool part about this is that you can actually write your own, right? Like that's a part of syntax that's actually pluggable that you can dynamically do. You can dynamically insert your own types of directives, right? And so that's really, really cool because it allows you to kind of build a markup language for your domain that's custom for what you're doing, right? You can't, I don't believe, you can nest them actually, yeah. So you can do you can recursively parse them. That gets a little bit crazier. This tutorial is not gonna cover that. But as a user, you can do that, assuming the directive supports it. And so, a really good example of this is, just a code block, right? So you wanna say, I'm gonna make a code block. I wanna syntax highlight it as Python. And this is actually an argument which says, give me line numbers on the output, right? And so that actually generates, output that has line numbers, right? And if you removed the little line number argument, the line numbers would go away, right? It gives you a lot more power than other documentation tools that you might be familiar with. So the second type of kind of extensibility is inline markup. So this is actually markup that's within your prose content. So like within a paragraph, you can actually do stuff like the PEP8 example, right? That was an example of inline markup. You're just going along writing, and inside of a piece of content, you actually want to kind of insert stuff. And so this looks like kind of a role and target syntax. So PEP8, like this, right, will create a link to PEP8. That's an example of inline markup. So here you can see, this is our inline markup, and then this is a doc inline markup, and so that actually basically says, I want to link to this document within this Sphinx project. And so I want to link to our style guide, right? And so that will magically generate an HTML link to the rendered output that is the style guide. But the really, really cool part about this is that when you generate a PDF, it works too, right? Because this is not HTML, right? This is restructured text, and it has its own internal model. When you generate other output formats, it can automatically create those links as well. And that's really the power of kind of using a semantic language in the back instead of just, we're just going to write this in HTML and, throw Markdown around it.
The keyword F, somewhere you have to write the link, right?
Right. So Sphinx automatically includes the PEP argument. Right. So Sphinx ships with all this stuff, right? So restructured text is what gives you the markup that allows you to kind of insert custom words. And then Sphinx is a set of extensions to restructured text that give you these concepts, right? So PEP8 is actually a Sphinx extension that basically will link to Python PEPs automatically in your documentation. So yeah, so anyway, so this, when this gets rendered into HTML, it turns that into a link to PEP8, and then it pulls, the top heading of the style guide document and creates a link with that as the link text, right? So yeah, so that's restructured text. So Sphinx kind of builds on top of restructured text and gives you a full project-based view of the world. So the first part of the tutorial is going to cover this, but it basically, within your project, you'll have a docs directory, and then you'll have these set of files. The conf.py is the configuration file. The make file is actually just a helper that allows you to build the docs easier. And then a set of restructured text files that will be marked up in this language. So to build your documentation, you basically just go in and run make HTML inside of a docs directory. So Sphinx is really the best documentation tool that I've run into. I run the largest software documentation conference in the country that was last week here in Portland. And nobody else has better tools than this. And it was actually built to document Python. So they built Sphinx to document Python, then extended it to be able to be used generally, and now it's a tool that's available to anyone to use. But given that heritage, it works really, really well at documenting Python. And so Sphinx kind of took restructured text, and it added a series of additions that make it a lot more powerful. So restructured text and Markdown, by default, just have like one page in their worldview, right? They're like, just give me some markup, and I'll output a page. And there's no way to kind of tie pages together into a full set of documentation. And so Sphinx solves this with what's called the talk tree, or the table of contents tree. And this actually allows you to build a hierarchy of your documentation. So in the index.rst, you can put a talk tree that then links to other pages, and that creates the actual structure of your documentation. And you can also link to deeper talk trees that then link to other pages, right? Like it actually does form like a tree structure with multiple indexes and all this kind of stuff. It takes a little while to wrap your head around this, but it's incredibly powerful. One of the other big ones is it gives you is cross-referencing. So when you add multiple sets of documents, you need ways to link between them. And so you can do ref, which is actually just a dynamic pointer to anywhere in a document. You can just do arbitrary referencing endpoints and then use those as references from other places. And also has things like the doc reference, and then you can actually reference APIs. So once you generate your Python API documentation, you can semantically reference them with like function names or class names. It has tons of code-specific markup, right? So you're like, I want to talk about this RFC or this PEP or these a environmental variable or a keyword or just these words that mean things to programmers. Sphinx kind of introduces those concepts into the documentation tooling. It has syntax highlighting. It has a series of extensions that we'll cover a few of in the talk, but it has extensibility built into it. Autodoc is another really powerful one, and this is how you automatically document Python code. So you point it at your Python code on the file system, and it will automatically generate sets of documentation that are API references from that code. And so if you actually put restructured text into your doc strings, it will automatically support that and work pretty natively. So the whole point of this tutorial is to cover that stuff in more depth. So don't worry if that was a little bit too fast and you're just like, what is going on? So that is what we're going to be talking about today and what we're going to be walking through. And so just to cover kind of where Read the Docs fits in this, we basically are just a web service that sits and provides automatic documentation building for Sphinx projects. So if you have Sphinx documentation checked into your repository, you just import your repository to Read the Docs, and then every time you hit us with a webhook, Travis CI build your tests, we build your docs, and then we host them for you. And so we have this beautiful theme, which I'm sure if you're a Python developer, you've probably seen once or twice. We support versions. So if you have different tags and branches in your documentation, those are able to be exposed on Read the Docs as versions of your docs. So you can have the latest, which is master branch, but then you can also have your last few releases that are tags, all hosted kind of for people that are on different versions of the docs. We also have post-commit hooks. So if you're on Bitbucket or GitHub, that integration just works automatically. You can also build your own if you're hosted in some third party. We do have just a generic endpoint. We do support Markdown for prose content. This is actually within Sphinx. But if that's something people are curious about, if you want to do like a little blog or kind of more text content somewhere that's independent in Markdown, but then have your actual API references and that kind of stuff in Sphinx, that is something we support. We just do translations as well, using gettext and kind of standard Python tools like transifex. Localization, readthedocs.org, I believe, is localized in 8 languages fully, but then there's maybe 5 or 6 others that are part of the way there. So if you go to Read the Docs in China, like the entire interface is in Chinese, which is incredibly hard to design for, but is really cool. We also do search. So Sphinx has search built in, but it uses this crazy JavaScript search that's really, really difficult because it's not actually a search engine. So we do index everything into Elasticsearch and then make that searchable, with like real search. We support CNAMEs, so if you have a custom domain, lots of people, pip and fabric and all these tools use, requests, use read the docs on a CNAME. And then we automatically build multiple formats for you as well, right? So Sphinx can generate PDFs just as well as HTML, and so we do all that. And so using read the docs is really simple. You just go to the site, you register for an account, then you import your repository that presumably has Sphinx documentation in it, and then we automatically pull that down, build the documentation, look for your requirements file, or pip install it if we need to, and then generate documentation for it. All right, that is the introduction to the tutorial. Now, the tutorial. So, if everyone would go to the Sphinx, so probably the easiest way to do this is sphinxtutorial.rtfd.org. And everybody has internet that functions? Sweet. Good job, PyCon. And that should land you on a page that looks very similar to this. Yeah, it's just PyCon 5G or 2.4. Yep. Sphinx tutorial. You can do readthedocs.io. That's the actual URL you'll hit. You can also do .rtfd.io, which is our short URL. All right. And so, when you go to this page, yes, the internet is rather slow, is it not? I will use a local copy. Because that is the beauty of Sphinx, is I have all of this building locally as well. So here we have basically just, I think we're right at 9:30. Yep. So that was the introduction. So the first step of the tutorial is basically just a little bit more of the overview that I gave you in text form, and then just installing, the actual project. So at the top of this page, I just cover a little bit of kind of philosophy around Sphinx. So if you actually want a little bit of what I just told you with links and that kind of stuff, but then the actual tasks are going to be installing it. So if you already have pip installed, you can just do pip install Sphinx. If you are still using easy install or something along those lines, it should work just fine there too. Then you can go ahead and clone this repository. And so that is going to be the repository that has all of the stuff that you need to do the actual projects. So that will have kind of the plain text markup. Yes? Yeah, you're definitely, you're welcome to do a virtual env if you want. It is not documented as such. It probably should be. All right, and then basically we're going to go through and just do a Sphinx project quick start. So I'm going to stop talking here. But yeah, did everyone successfully at this page? Joy of internet. All right. Yeah, so maybe just you can open tabs to the new windows. But yeah, so I will go ahead and stop talking and give folks about 15 to 20 minutes. So what you're going to be going and doing is basically just installing Sphinx and then creating a new Sphinx project inside of your docs directory, and then building the documentation. So hopefully at the end of this, in about 15 minutes, everyone will have a local Sphinx build that is pretty much empty, but says, hello, welcome to Sphinx. So who here has completed the install so far? All right. Who here is done with the whole page? Okay, so like 60, 65%. I'll give folks a couple more minutes. Obviously, it's important that we have things installed before, we do other stuff. All right. I think I'm going to try and move on. If folks don't have Sphinx at least installed in building, please go ahead and raise your hand, and Anthony will come help out. I think everyone else is at least that far, so cool. So that is basically all you need. The theme and all that stuff is kind of a cool addition, but for the most part, we really just need Sphinx installed locally on your machine. So we're going to go ahead and go on to step 1, which is really delving into restructured text and how it works. So just kind of some logistical things. You'll notice here we actually have each set of documentation that we're working on built. So over on the left sidebar, the kind of step 1 stuff there will actually give you, this is basically at the end of this step what your docs should look like in terms of sidebar and front page. And we're going to have just a basic index with an installation section and then a support page. And so, we're going to build more than that with API references and that kind of stuff by the end of the tutorial. But for now, we're just trying to get that basic restructured text and all that stuff in there. So kind of the concepts that you're going to need to know for this particular section. You need to know how to do section titles. So section titles are basically just underlined with some type of markup. They're pretty arbitrary, but I do recommend being consistent. So using kind of a double underline for titles, single for section, and then some squiggly lines or other stuff like that for subsections. You shouldn't have to get any deeper than 3 sections. In terms of code samples, you can use backticks for those, and that basically just makes the output look highlighted. You can do hyperlinks with backticks around it and then an underline. So this is the single worst part of the syntax for restructured text. So if you can get this down, you'll be good. And I'm sorry that it's so ugly. I am working to improve this in the language. And then so then you basically just take this content and copy it at the bottom with 2 dots and an underscore, and that actually completes the symlink, or completes the link. It's really stupid, But there are other ways to do it, but this is kind of the most canonical.
Where do you usually put the
So you can put it at the bottom of the page, or I generally try and do the bottom of the section. So basically, you have a heading that's like a section and it has a few paragraphs. I try to keep the links at the bottom of that section of content, just so they're not, you don't need them every paragraph, but at least kind of it naturally keeps them together. So then for code examples, so it has this kind of cool little feature where you can actually do 2 dots at the end of a paragraph, and that will turn into just a single colon, and then it will make the bottom part a code example. So here you can see that's going to be a code example. And then you can also syntax highlight stuff with the code block. So you can say, code block, and I want this to be highlighted as, RST or Python. And then again, indented below that is the content. And then the table of contents tree that I talked about, this is how you're actually going to, tell Sphinx that these different RST files that you have on your disk are actually part of the same project and should be placed into the sidebar. And the ordering matters, right? So the way that you order these will actually be the ordering that they appear in your sidebar. And yep, so that's kind of the basic stuff that you're going to need. All that's also on the cheat sheet, which you should have next to you if you're really curious about kind of the syntax and all that stuff. So what we're going to do here is you're going to basically make an install.rst that has the installation instructions. And so here is the actual, the content. Like I was saying, this is just plain text content that you're going to have to go in and actually, put the proper restructured text around it. And then you can see the live preview is linked just below it. And then we'll also do a support page here that is similarly the empty content, or the content without markup. And then you'll have to go ahead and add your table of contents tree to pull all those pages together into the index. And then you'll build your documentation. And so then if you're feeling crazy and you get finished early, feel free you can make a man page out of your documentation, which is kind of cool. Just shows kind of the other formats that you can generate. You can also generate a single page piece of documentation as well. So all your different pages will be kind of concatenated together into one page. And then, yeah, if you still have a little bit more time, we're going to try and take about 20 minutes to do this, maybe 25, and then we'll have a break. So kind of it looks like there's already starting to be some snacks and stuff out there. So once you finish with this, don't feel like you have to kind of hang out. So in about 23, 25 after 10, we'll be called a break, and then we'll be back here about 10:45. But feel free to take off early, or ask me questions or anything if you get done a little earlier. All right, question.
Is 3 spaces kind of the standard indentation, it seems like, in RST?
So 3 spaces is the standard indentation because it makes it line up. So the dot space content. I know it's weird because most people use 2 or 4 or 8. But yeah, so 3 spaces. And then the other probably thing that I should note here is that you do need to have a space after these directives. So if you try and put the content immediately under them, it thinks that's probably going to be an argument or something like that. So you do need to have that space there. So if you just start getting crazy, weird things that happen, that's why. And yeah, and I will let folks get started, and I will hover around and help out. Hope everyone is now caffeinated and happily full and all that good stuff. So, just wanted to touch on a couple things that kind of came up during the break and whatnot. So this is so the link syntax actually is actually just an underline. So this GitHub link and then the ... underline GitHub is actually the link syntax. The backticks are a grouping syntax. So the backticks allow you to have spaces and other stuff inside of that. So if you're just, the problem is that nobody knows what this little thing means. And so in general, even if you're doing a single word link, you should still use the backticks just because people have learned that that's the link syntax. But it is slightly less ugly this way. It yes, you can backslash escape things. So the reason that they gave that this is the link syntax is that it looks like a tail, and so the tail is going out into somewhere else and is a link to another place in the world. I mean, who doesn't know that? Like, I mean, that's obviously. All right. So now you have been fed and snacked and caffeinated. So now we will delve into the meat of this tutorial and some of the more interesting stuff. So we're going to talk about documenting Python, right? We're here at PyCon. That seems like something that we should be talking about. And so for step 2, we're actually going to go through and build a reference for your little library. So here, in the little intro, I talked a little bit about referencing. So this is how you define a reference name. You'll notice it is the exact same as the link syntax. So the link syntax, if you put a URL on the end of it, says I want to link to a URL. This is actually saying I want to link to this section. So it's the exact same syntax for links, but it allows you to link to arbitrary places in your document, which is actually really cool. So that's part of the reason that this is kind of crazy, right? Is that you're actually defining, it is a directive that defines a link that can either be a link to a URL or a link to a place. And then those are referenceable with reference. So here, we've created a reference name, and then we can reference it with ref to that name. You'll see you don't include the underscore at the bottom. It is just the content. And then because we're referencing a section, this reference will actually turn into a link to, that contains as text the heading of the section. There is a way to reference arbitrary points that don't have section headings, and if somebody wants to do that, you can talk to me. So then the other way you can do this as well is if you're actually just wanting to link to a specific document, it works the same way, right? You just do a doc with the actual name of the document. So this is the same name as you would use on your table of contents tree, right? There's no extension. It's just kind of the path to the document on the file system. So one of the other really cool things you can do is you can actually document software concepts. So here we're actually going to document an argument that the command line utility that we built takes. So it's called an option. So here you have a directive, right? It's the normal directive syntax, but then the arguments to it are the markup that is, what the command line directive is. And then the actual content down here is the description of that argument. And then what's really cool is those can then be referenced. So in your other documentation where you want to be like, hey, if you want to, ignore this regex of URLs, just do option I, and that will automatically link you to the reference to that command for the user to look up. There's a bunch of other ones that Sphinx has. You can do, modules, you can do classes, you can do methods. This is kind of the core of actually documenting code inside of Sphinx. So similarly, we already covered most of this, but you can also do external references with PEPs and RFCs. And there's a full list of things in Sphinx's inline markup docs. And so, obviously, it's really kind of arduous to write this stuff over and over and over. So Sphinx ships with a tool called Autodoc, which is the Autodoc extension. And it allows you to actually just say, automatically document this module crawler. And that will it actually imports the crawler module in Python. So it's like import crawler, and then just like actually pulls all of the contents of that module off, generates RST, and documents it for you.
So does that put in the
So this is in RST. You have to enable the autodoc extension in your config file. And you also have to tell Sphinx that you have to let Sphinx know in the conf file of the file path. So you actually have to add the crawler to the Python path for Sphinx. And that, I'm 99% sure that's covered in the tasks below. But if it doesn't work and you're like, crawler module not found, that's because it is literally trying to import that module just like you would at a command line import Python or import crawler. Yeah, that's this big warning here is that. So anyway, that's what we're going to do in this step is we're going to go through and we're going to build out a cookbook that is just manually referenced. So that will look like this. So you'll just have some basic examples, but those examples are actually using references that go to the actual reference to the command line options. But to start off, you can just go ahead and build them normally. And then we'll build a CLI.rst, which is the actual part where we're documenting these different options to the command line. And so this is where you'll actually start putting in those options and those kind of reference targets. And then you will make your docs. And then after that, we'll actually start a little API.rst file where you'll automatically be pulling in your source code. So this is where we'll introduce the autodoc tools. So you'll actually be able to just say, look at this Python code on disk and generate an API reference from it. And that will look something like this. So, yeah, so this is where the part where you have to tell Sphinx about your code. That's what I was mentioning. You'll change this little, system.path insert part. All right, and then you're just going to tie that all together back into the talk tree at the end. So this is definitely getting a little bit crazier, introducing a lot more kind of deeper concepts inside of Sphinx. And then if there's extra credit for folks, if they get ahead, InnerSphinx actually allows you to semantically reference with docs and references and APIs across Sphinx projects. So you can actually reference the Python documentation directly, which is really cool, or the Sphinx documentation. But yeah, I will stop talking because there is a decent amount to cover here. And so we're going to take about 25 more minutes from now, maybe. So it's 10:50. So at 11:15 we will start to move on. But I will stop talking, get started, and we'll wander around and help you with questions. and it knows when the pages on your disk change, and actually creates a cache and will only rebuild pages that have recently updated. So if you want to go through and clear away all that cache and rebuild everything, you do make clean and then make HTML. So if you're getting like things where it's like, oh, this one page has a menu that's out of date with the other menu or that kind of stuff, that's what's happening there. says auto module working. So we got like 6 people. Sounds about right. It is really, really tricky to get the auto doc stuff working. Who is trying to get auto doc working but did everything else?
And who is trying to get AutoDoc working is on Python 3. Okay. Have you run into issues with AutoDoc? Yeah, the module is not written in Python 3, so it'll throw some errors.
It used to work in Python 3. I tested it.
That's the older version of Beautiful Soup. I mean, if you get Beautiful Soup 4, but then there's a relative.
So now you all see the folly of trying to import code to document it. We are working on a tool that will actually document Python code without importing it, because importing it is dumb. Because you need the entire, especially with like C libraries and scientific Python, a lot of that world, like trying to be like, oh, you need NumPy in order to generate documentation for my library is crazy. Yep. So there is also a way in Sphinx. There's a configuration option that allows you to mock out import statements. So when you do AutoDoc, it will actually return mocked variables for imports. So as long as you're not doing anything at class level with your imported code, you can actually just mock out all the imports, which is probably what I should have done for this tutorial, but in the past that has had issues as well, as with all things. All right. So it is 11:30, which means we have 50 minutes left. So I'm going to try and move on. If folks are still on the last step and are stuck, we can still come around and help out. But for the people that have made it this far, we can at least talk through the next section. All right, so I'll just talk for like 3 or 4 minutes, just so people kind of know where else. All this stuff is online, so if you don't finish every step, you can always come back and do it later as well, if you need to. So the last step is going to be testing your code examples and actually kind of looking at how to keep your documentation and code in sync and up to date. So Sphinx has this really cool module called DocTest, which actually allows you to put in test code or put in tests of your example code in your documentation. So Python ships with DocTests, and Sphinx just ships with support for this. So if you actually go ahead and add this into your document, it will run that function sum and actually confirm that it outputs as 4. And so, for example, that will actually output to the user as documentation. If there's stuff that you want and you need to kind of actually set up the tests that you don't want to output to the user, the test setup directive does that. So, right, like this, say you need like a variable or some imports or something to actually make your example work, but you don't want to show the user that, you can just do test setup ahead of that, and it will run those commands, and they won't be output to the user. So that's just a really, really simple example. For this code, we're just going to do a little example for the actual library that exists. And then also, the last step is uploading your docs. So everyone doesn't have this in Git repos, and the internet's going really slowly. So at the end, in the last like 10 minutes, I can just upload my version and show people how it works. If you're feeling confident and you get to the end and you want to put your code on GitHub, feel free to do this, but don't feel like, I'm just going to kind of show you how it goes, and it's pretty simple. So what you're going to be doing is just adding doc tests into your API file. So here you have your kind of normal API with it actually has this should ignore function, which is what implements that regex ignore. And so should ignore, on this, with this blog regex on agriculture.com/blog, right, should return true. And so these are just examples of things that should work. And then this isn't actually a test that should fail, right? So you can put that in and actually see the test failing. And then similarly, there's a logging function that's very, very simple. That's just going to, output a URL with a status code. And it puts errors in front of 500s and all that good stuff. And so these are examples of passing tests with, the test and the output. And then this one, should fail. So you can go in and add those examples to your docs. And then, so this does, of course, depend on being able to import the code. So if you haven't gotten there yet, you still need to do the auto module stuff. But yeah, and so this will actually allow you to generate examples in your code. And so this is pretty cool, right? So you get these little, these little example output things in your user documentation that you can actually validate as part of your test suite. So it's like, do the code examples in our docs actually work? Yep, and then you can actually run a make doc test command, and that will go through and run all of these code examples and give you a little doc test summary output. So this is actually how you can go in and test the code samples in your documentation to make sure that they work with your up-to-date source code. And then after that, there's a little bit of how to actually update your code to go on read the docs. So you have to add a requirements.txt file with these requirements, and then you just upload it to read the docs. And you can do that if you get there. If not, I'll just go over it. Yep, and so that is what is going on here. Feel free, I know the auto module stuff is kind of hard and crazy, so we will still kind of walk around and help people out with that as well. And then if folks get done a little bit early, the last page of the tutorial has tons of resources and other things you can do. So there's a really good tutorial for developing Sphinx extensions. You can import, Java doc and some other types of documentation. You can add Markdown support in Sphinx. You can add Django support. You can play around with the internationalization stuff. And yeah, and some tables and all sorts of good stuff. So there's kind of a choose your own adventure at the end, and as well, if you have something specific that you want to ask me or are curious about, I'm always happy to kind of direct folks because I know the tool pretty darn well. But no rush to get through faster. I just wanted to kind of talk through that for the folks that are there. And now we can go back to the part of the tutorial you're at, and we'll help you kind of keep going. So. All right. So we are about 8 minutes from the end. And so just so folks have a little bit of context, I think the internet's going too slow to really do much of anything. But all right, so this is just going to be a basic kind of read the docs example. So I just added something to the index, which is a little thanks for coming on our tutorial. And so then I just committed that or not. Now actually committed it. And so I'm just going to push this to GitHub. And then when that goes to GitHub, GitHub is configured to send a post commit hook to read the docs. So that just sent a post commit hook to read the docs, which triggers this build process. So now the build is, installing and all that good stuff. So it's actually, creating a virtual env, installing your requirements, running the actual Python code, and then generating PDFs and all that good stuff. So we just completed a build. So here you can see like your comp.py and all that stuff if you need to debug it. So then if we actually go and view the docs, there's a little, thanks for coming, in the live tutorial that you all now can see on the internet. So basically you just go in, and if you wanted to import a project to read the docs, you just create an account, and then it will give you can connect it to GitHub, and it will give you a list of projects that you can import, and you just click import, and it will automatically pull them down, right? So I have a bunch of different projects in there, but I can just hit a plus, and it'll drop me into an import. I hit OK, and it will pull down the code, automatically build them, all that good stuff. So that is if you actually want to take Sphinx documentation and host it and have it automatically updated. So I don't think this thing actually has any versions. But so if you have an actual project that has like tags and branches, that will show up here in your versions. So you can go ahead and like make those active and all that stuff. So if I wanted to push a release of 6.4, I could go ahead and do that. But yeah, so that's when you actually want to go and deploy your Sphinx code and have it auto updated with your libraries and all that good stuff. So yeah, there's about 5 minutes left. Feel free to hang out for a little bit. We'll be around to answer questions. Please give feedback. Yeah, I know I already updated the tutorial with the install requirements part, so sorry that was not there. Yeah, and otherwise, hopefully people enjoyed it, and you can kind of see why Sphinx exists and how it's powerful. And yeah, feel free to kind of find me. I'll be around the conference all week. I'm local, so I'm easy. I'll be here through the sprints. Yeah, and if you want to work on Sphinx or restructured text or any of this stuff, read the docs during the sprints. We'll be around, so definitely come find me. And otherwise, have a good rest of the conference, and thank you for coming.